column was based on the different output and input variables. But when we are talking about functional units, so our focus will shift from the different operations that we have, the different operations that we were talking about in terms of V1, V2, V3, and V4, and it's you can say split into the different time steps. So this is how we like. Now we are into the operation level. We will be mapping the operations to the different, you can say, functional units in this particular step. So say for example, during this entire you can say exercise, where I'm using say three multipliers. So if I represent them say with M1, now M1 say I can use any of the operations. I can use any of the operations from this particular graph. I can use this, say, for example, V1 and V2 is one operation that we have. Again, V2 and V3 is another operation for this adder. So, for example, if you have another kind of an operation here where you are bringing in from this 2, so I can represent that by V6. So here basically we are not talking in terms of variables. We are, since this is a functional unit allocation, so we will be talking about the different functions or the operations that we had encountered during this entire, you can say, scheduling step from the detail graph. Therefore, the first column that we had in the register allocation, you can say step, is going to change, but this particular time steps are going to change.
এটা হাফ হয়ে যাবে তো ভাগ, আইটিসি তো
So
হাফ হয়ে যাবে।
you can have,
হ্যাঁ বেশি
so you can have,
সেটা যদি আলাদা আলাদা করে কোনো অসুবিধা নেই, সেটা একবার জিজ্ঞেস করে।
yeah. So we can see if we can reuse these multipliers. So basically that will again depending on whether the operation V1, the multiplication of this V1 and V5 or V2 and V3, these are occurring in that particular time step or the different time steps. So maybe during your entire, you can say, execution, you may have 6 multiplication operations, but they may be distributed over different time steps. So basically that entire task of 6 multiplications can be done with 3 multipliers. So this is what happens in the functional units. It is exactly same and similar to the register allocation, you can say, step. The functional unit allocation and binding is very similar to the register allocation and binding step. The only difference is that here we are talking in terms of the operations rather than the variables. So after this, as we had discussed in the beginning of this, you can say, session, that once we are done with this, once we have allocated different variables to the registers and the different, you can say, operations to the functional units, we move into the data path synthesis. So during this data path synthesis, you can observe and you can try to understand uh, yeah, so how this data path synthesis is done, or you can say using the steps that we have come from. So basically when we do this, when we talk about this data path synthesis and controller synthesis, although we are talking it very simply during this talk, it is a very complex process and it goes through the different other steps of compiler optimization which we have not discussed here in your the entire VLSI design flow of the HLS step. So here, what basically is represented ultimately, if we recall, the ultimate objective of high level synthesis is to convert something from a behavioral description to an RTL. That is what we have been reiterating during this entire discussion. So if we define, say for example, two you can say systems, or say for two multipliers, say for one multiplier I'm representing it as a system. So I had these operations earlier, so where say for example I can represent this as this one, and again I can use this as say 3 into x, and v4 as u into dx. So it was something like this. And after everything is done, now this particular step that we see here, This was only a translation of the equations that we had written, or the you can say the expressions that we had done. We had only segmented this and represented this in terms of variables. So we had only represented and expressed this in terms of variables. Now the point is that we want to bring this to the hardware. And during the intermediate steps, this was a part of the pre-processing step, if we can recall. So during the intermediate steps, what we have done, we have done the register allocation, where we have allocated, we have mapped each of these variables into